You ever wonder why your favorite streaming app can handle a massive premiere night without a single hiccup, but your banking app totally melts down on the first of the month? Well, it's not magic, and it's definitely not luck. There's a hidden science at play, a whole field dedicated to figuring out why some of the digital services we rely on are rock solid, and others, well, they just aren't.
So that's the big question, right? When thousands or even millions of us are all trying to use an app at the exact same time, what's the difference? What separates the apps that can take the heat from the ones that just crash and burn? Honestly, it's one of the biggest puzzles in modern software engineering. And here's the wild part, the secret sauce, if you will. That reliability we crave, it's not an accident. Nope. It's the result of engineers methodically and intentionally trying to break their own software in a controlled lab. It's this fascinating world of performance testing where they essentially become digital crash test dummies to build stronger, better apps for all of us.
Okay, so to figure out how strong an app really is, engineers need a way to measure it. Think of it like a car's dashboard. There are a few key dials that tell you exactly how everything's running under the hood. We'll call it the performance scorecard.
First up on our dashboard, response time. You tap a button in an app, how long till something actually happens? That's its response time. It's basically the 0 to 60 for your app's actions. You want that number to be low and snappy for a great experience. A slow one? Yeah, you know the feeling. We've all been there, staring at a loading spinner.
Next, we've got throughput. Now, this isn't about how fast one single click is. It's about how many clicks the app can handle at once. So if response time is the acceleration, throughput is the car's top speed. It tells us how many people can use the app at the same time before the whole thing starts to bog down.
And finally, there's the error rate. This is the big, blinking, impossible-to-ignore check engine light on our dashboard. It's simply the percentage of requests that just fail. A high error rate is a huge red flag that tells engineers there's a serious problem somewhere that needs to be fixed, like yesterday.
So let's look at this in the real world. This chart is really interesting. It compares two popular applications, WordPress and Ghost. Now, WordPress has what's called a three-tiered architecture. Basically, its user interface, its brain, and its database are all separate pieces. Ghost uses a simpler two-tier setup, and look what happens under a heavy load. The more complex WordPress app is way more stable. Its response time barely moves while Ghost's is all over the place. This is a huge insight. Sometimes, having a more sophisticated structure where different parts do their own jobs is exactly what you need to handle serious pressure.
Okay, so knowing an app's basic stats is one thing, but what happens when demand doesn't just grow, it explodes? This brings us to the next level, the great scaling test. Think of it like this. It's one thing for a single chef in a restaurant to handle a few tables, but it's a completely different game to serve a packed house on a Saturday night without the kitchen catching on fire.
In the tech world, that challenge has a name, scalability. It's all about a system's ability to ramp up, to add more capacity on the fly, like that restaurant calling in more chefs and waiters to handle a flood of new users, all while keeping the quality of service top-notch. It's not just about handling more, it's about handling it well. Now, in a perfect world, what engineers call ideal scaling, an app's response time would stay perfectly flat, no matter how many millions of people you threw at it. But, you know, we don't live in a perfect world. In reality, there's pretty much always some slowdown as demand goes up, and the entire science of scalability testing is about measuring that gap between the ideal and the actual, and then trying to engineer ways to make that gap as tiny as humanly possible.
So, why are we even talking about this? Why does it matter to you? Because this is the science that lets millions of us watch a season finale at the exact same second without a single glitch. It is the invisible engineering that lets our digital world handle its biggest, most exciting moments.
But, and this is a big but, all of this testing and measuring creates a really fascinating problem, a paradox even. To find performance problems, you have to measure everything. But what happens if the very act of measuring is what's causing the problem in the first place?
Yeah, let that sink in. This is the heart of what's called the measurement paradox. It's like trying to measure an Olympic sprinter's top speed while forcing them to wear a heavy suit full of sensors. The question becomes, how do you actually observe a system without fundamentally changing the thing you're trying to observe? The technical term for this process is code instrumentation. It's where these automated monitoring tools go in and inject tiny digital probes right into an application's code to collect all that data we need. It is absolutely essential to see what's going on, but as you're about to see, it doesn't come for free.
So have a look at this. This is the baseline performance of an app with no monitoring tools running. See that? The response time is low, the system is humming along nicely. This is our before picture.
And here's the after. Just by turning on those monitoring tools, look what happens. The average response time jumps up a lot. The system got slower just because we started watching it. The very act of observing it changed the outcome.
And this isn't just a feeling. We can put real numbers to it. One study found that having this instrumentation active dropped an app's overall throughput by about 8.4% on average. And in some cases, the performance hit was over 30%. Think about that. The very tool you're using to find the slowdown is the slowdown.
The researchers who found this were crystal clear. This quote says it all. They're basically saying the slowdowns they saw weren't because the apps were built badly. No, it was a direct result of the overhead introduced by instrumentation. In plain English, the monitoring tool itself was the problem. It was the bottleneck.
So, with all these challenges, what's an engineer to do? Well, the most forward-thinking teams are moving past just fixing problems after they happen. They're trying to engineer systems that are designed from day one to not just survive chaos, but to actually get better because of it.
And this brings us to a really powerful idea. We all know what resilience is, right? It's the ability to get knocked down and bounce back to where you were before. But the next step, the real cutting edge, is something called antifragility. An antifragile system doesn't just recover from stress and chaos. It actually gets stronger, smarter, and tougher because it was stressed.
So how in the world do you build something that gets stronger from failure? Well, one of the wildest techniques is called chaos engineering. And it's just what it sounds like. First, engineers deliberately break things in their own live systems. They'll inject network delays, shut down servers, you name it. Then they watch carefully to see how the system reacts. And finally, they use that data to evolve the system to make it stronger for the next time a real failure happens. They are literally using chaos to fight future chaos.
And this whole field is still moving at light speed. The next big thing is already here, using AI. Researchers are now training large language models, the same kind of tech behind tools like ChatGPT, to automatically generate smarter, more creative, and way more effective performance tests. It's pushing the limits of what we thought was possible for building truly unbreakable software.
So the next time you launch an app and it just works, take a second to think about the hidden science that made it happen. It wasn't just luck. It was this intense, deliberate, and even chaotic process of breaking things on purpose, all to build them back stronger for you. So what hidden chaos do you think that app had to survive, just so it could work flawlessly on your screen?